Welcome to DjamgaMind, your ads-free audio intelligence platform. I'm Etienne Noumen. It is March 8, 2026. This week, we saw the birth of the sovereign desktop. As OpenAI releases GPT 5.4 and Apple democratizes high-performance local AI with the $599 MacBook Neo, the cloud's monopoly is fading. Simultaneously, the Pentagon and the Supreme Court have begun setting the legal and military boundaries for the next decade. No fluff, no ads. Let's dive into the weekly rundown.
Welcome back to the Deep Dive. Today, we're really bypassing the usual news cycle hype. Everyone else out there right now is just arguing over raw parameter counts and theoretical compute limits.
Right.
But we're looking at what actually matters when you, the listener, are mapping out an enterprise tech stack. We're looking at what we're calling the architecture of control.
Exactly. Because if you're building deployment strategies right now, the actual real-world battle isn't just about which model is technically the smartest.
Oh, not at all.
The battle is being fought over the architecture itself. I mean, how are these systems actually deployed? How are they governed? And ultimately, who controls the underlying economics of the entire stack? If you don't understand those shifting foundations, you simply cannot build a sustainable strategy.
And to map that architecture for you today, we are unpacking 4 distinct layers from our latest stack of source material.
It's a heavy stack today.
It really is. So first, we have the model layer. We're looking at the rollout of GPT 5.4 and how the economics of something called tool search are basically changing the math for developers.
Huge implications there.
Then we look at the hardware layer, where Apple has just completely disrupted the board with a surprisingly cheap new MacBook. Third is the legal layer, digging into a quiet U.S. Supreme Court decision that, well, it basically functions as a hidden tax on AI productivity.
Yeah, that one is going to catch a lot of architects off guard.
Absolutely. And finally, the security layer, where we're going to look at the incredibly jarring contrast between pristine, automated code security and, well, messy human data pipelines.
It is a densely packed map, but every single one of these layers intersects. You really need to see how the model layer's economics dictate the hardware layer's viability, and then how the legal and security layers constrain literally everything you actually want to build.
Okay, let's unpack this with layer 1, the model layer. So OpenAI just launched GPT 5.4.
Right.
This is a new foundation model explicitly designed for professional work. They released it through their API in 3 distinct versions. We've got Standard, Thinking, and Pro.
And the context window on this is...
It's massive, a 1 million token context window.
Yeah.
For you listening, think of the context window as the model's short-term working memory. 1 million tokens means you can basically drop entire textbooks or massive sprawling code bases onto its desk all at once.
Or just dump it right in there.
Exactly. And of course, it is posting record-breaking benchmark scores.
Right, but we do have to be careful with benchmarks. The industry loves to throw alphabet soup at us to see what sticks.
True. But the ones they're dominating on right now are quite specific. They hit record scores on OS World Verified, Web Arena Verified, and Mercer's Apex Agents test.
The Apex Agents test.
Yeah, that last one is a major benchmark for aptitude in law and finance specifically.
And that is exactly where the signal is in the noise. Mercer's Apex Agents test isn't just another standardized math quiz or a trivia game. It actually tests if an AI can execute multi-step corporate finance tasks without hallucinating or just completely losing the plot halfway through. But what's fascinating here is that the real story for an architect isn't just the benchmark dominance. The real story is the economics of a new feature they've introduced alongside it called tool search.
Yeah, I was looking through the technical documentation on this. When you're building complex enterprise AI systems, what we call agentic workflows in the field, your model isn't just generating a poem or writing a polite email.
No, it's doing actual work.
It is actively reaching out and calling multiple external tools, like a live weather API, a proprietary customer database, a flight booking system, all in one fluid motion.
And historically, that process has been incredibly token intensive, which translates directly to being incredibly expensive. It's like, imagine hiring a contractor who charges you by the word every single time they have to open the instruction manual just to remember how to use their own hammer.
That's a great way to put it.
Every time the model has to process the instructions for how to use an external tool, it burns through tokens. So if it's calling dozens of tools across a complex workflow, that cost compounds rapidly.
So how does tool search actually fix that bottleneck? Because that's the real issue for deployment.
Right. Tool search is designed to drastically cut those token costs by optimizing how the model retrieves and understands those tool calling instructions in the first place. For the listener, the architect designing these systems, this is a total economic game changer.
How so?
It fundamentally shifts the bottleneck of your operation. The primary friction point moves away from the raw compute costs of running the model, and it shifts entirely over to the integration logic. You can now build highly complex multi-tool agentic workflows without blowing your entire monthly API budget in a single afternoon.
And there is another crucial angle to this release, which is the safety evaluation, specifically for that middle tier, the thinking version.
Yes, the transparency aspect.
The documentation explicitly notes that the new safety evaluation found the thinking version of GPT 5.4 is significantly less likely to misrepresent its own chain of thought reasoning.
It doesn't lie about how it got the answer.
Right. It actually accurately reflects how it arrived at a conclusion.
Which is the absolute cornerstone of enterprise reliability. If you are deploying an autonomous agent to handle finance or legal tasks, areas where we just established GPT 5.4 is explicitly scoring high, you cannot have a model that hallucinates its own logic.
You'd be flying blind.
Exactly. You need a verifiable audit trail. An architect can only build a robust, scalable system on a foundation that doesn't actively obscure its reasoning process. So at the model layer, we are seeing much cheaper execution of complex tasks, combined with a more transparent, reliable reasoning engine.
So we've got these massive models getting cheaper to run via API. And this is a big but cheap API calls don't mean much if your workforce or your customer base is still tied to massively expensive desktop hardware to process the local side of things.
The edge compute problem.
Which brings us to layer 2, the hardware stack. Here's where it gets really interesting. Apple just dropped a complete surprise launch, the MacBook Neo.
A total disruption of their own product lineup, honestly.
Absolutely. It officially replaces the 13-inch MacBook Air as your entry-level option. But the price point is what is turning heads everywhere. It is a $599 laptop.
$599.
It severely undercuts the $1,099 M5 MacBook Air. It goes up for pre-order today. It's available on March 11th, and it comes in 4 colors: silver, indigo, blush, and citrus. But let's look at the actual silicon inside, because it does not use an M-series chip.
No, they went a completely different route.
Apple put the A18 Pro processor in this laptop.
Right. They took a phone chip and put it in a laptop shell.
With a 6-core CPU and a 5-core GPU. But here is where I have to push back a bit on the hype from the hardware reviewers. It is strictly limited to 8 GB of memory.
Yeah, that's the sticking point for a lot of people.
Any architect knows that 8 GB is tiny. If you're trying to run a serious local model, 8 GB of RAM is going to completely choke the system. Is Apple really democratizing AI here, or are they just selling a glorified, colorful Chromebook to college students?
It's a very fair question. But if we connect this to the bigger picture, it is arguably a more dangerous move to Apple's competitors than the high-end M5 Max line.
Really? More dangerous?
Yes.
All right.
Because of how Apple handles unified memory and the neural engine on the A18 Pro chip, 8 GB can actually do a surprising amount of heavy lifting if the model is optimized. We are talking about quantized models here.
Right, and just for the listener, quantization is basically shrinking the AI's brain. You're rounding off the complex math so the model can actually fit inside a small laptop instead of needing a massive server farm in Virginia.
Precisely. You aren't going to train GPT-5 on this machine, but you can run a highly capable, quantized local assistant. By pushing the A18 Pro chip into a laptop shell at a $599 price point, Apple effectively democratizes access to robust on-device processing.
So they are securing the absolute base layer of the hardware stack.
They are establishing the lowest common denominator that developers have to target. For the listener building deployment strategies right now, this means local, edge-based execution just became radically cheaper and vastly more accessible for the average consumer.
Apple is flooding the sub-$600 market with edge compute-capable devices.
Exactly. If you are an architect, your strategy for where the compute happens, do we send this to the cloud or run it locally on the edge? Well, that strategy now has to account for a massive new install base of A18 Pro laptops.
It really is a pincer movement on the industry. The models get lighter and cheaper to run, and the local hardware gets cheaper to buy.
It's squeezing the middle entirely.
But of course, you can have the most efficient models and the cheapest ed hardware in the world, and literally none of it matters if you don't actually own the output.
And there's the wall we keep hitting.
Which brings us to layer 3, the legal layer.
This is where the frictionless promise of AI, slams headfirst into the very real friction of physical property law.
We have to talk about the U.S. Supreme Court. I was reading through the lower court rulings that the Supreme Court just recently declined to review. It involves a major copyright case with a computer scientist named Stephen Thaler.
The Debuse case.
Right. Thaler has an AI system named Debuse, and he basically sought copyright protection for an image that was generated entirely independently by this AI. Now, because the Supreme Court refused to hear the case, those lower court rulings remain firmly in place.
And the wording in those lower court rulings is critical.
The judges were very explicit. They stated that human authorship is a bedrock requirement of copyright.
It's a fascinating phrase, a bedrock requirement. And if we look at the structural implications of this, completely regardless of the legal philosophy behind it.
Right, we're just looking at the mechanics here.
Exactly. What we are looking at is the establishment of what we can call a human-in-the-loop tax.
The human-in-the-loop tax. I like that framing. Let's break down exactly how that works for an enterprise workflow.
Well, the Supreme Court's decision, and we should note, this perfectly mirrors previous losses for Thaler in the patent arena as well. It reinforces a very consistent position across U.S. intellectual property law. Fully autonomous AI systems cannot be recognized as authors, and they cannot be recognized as inventors.
So for an enterprise, the implication is massive.
Huge. You cannot simply automate a legal, creative, or developmental pipeline from end to end using AI and expect to retain the intellectual property rights to the output.
Because the law explicitly demands human authorship.
Exactly.
So as an architect, if you build a flawlessly automated, highly efficient AI system that generates code or industrial designs or complex legal documents, you still have to inject a human worker into that workflow.
You must inject a human worker. You have to establish that human authorship to legally protect the asset. That is the tax. You are paying a human-in-the-loop tax just to secure your intellectual property.
It is incredibly ironic. So basically, you build $1 billion AI infrastructure to do 99% of the brilliant, heavy-lifting design work.
Yeah.
But you still have to pay a guy named Days to sit there and hit approve just so the Supreme Court doesn't void your copyright. The human is almost functioning as a legal rubber stamp for the machine's labor.
And this creates a severe architectural bottleneck. Think about everything we just discussed in the first two layers.
The speed and the cost.
Right. You have GPT 5.4 making complex tool execution cheaper. You have the MacBook Neo making edge compute cheaper. But at the very end of the assembly line, the intellectual property framework forces you to bottleneck that incredible speed and efficiency through a human reviewer.
Dave at his desk.
Dave at his desk.
Wow.
It is an architectural constraint that every strategic planner has to build around right now. The workflow nightmare of documenting exactly what the human did versus what the AI did just to prove authorship, that is going to be a massive overhead cost.
Which perfectly sets up our final pillar today. Layer 4, the security layer. Because when we talk about inserting humans into the loop versus relying on automated systems, the contrast in how we build trust is staggering.
It's night and day.
We have two source stories today that illustrate this divide perfectly. First, let's look at OpenAI. They just launched Codex Security, which started internally as a tool called Ardvark.
Right, the code scanner.
It's a new tool inside their programming assistant that helps developers find and fix code vulnerabilities. It scans repositories and ranks flaws by severity. But the workflow is what is important here, because they are using automated sandboxing.
Yeah, and how does that sandbox actually work in practice?
Well, Codex Security essentially copies a code base, an entire repository, into a completely isolated digital container.
A clean room.
Exactly. It builds a mathematical threat model detailing exactly how the program is supposed to work, and then rather than just guessing, it actively tests the discovered flaws in that isolated sandbox.
To filter out false positives?
Yes.
Because anyone who has ever run a security scanner knows the sure pain of false positives. You get alert fatigue because the system flags 100 issues and 99 of them are completely harmless.
You just end up ignoring all of them.
Right. By actually executing the code in a sandbox, Ardvark proves whether the vulnerability is real or not before it ever alerts the human developer.
And this pristine, highly automated security tool is available right now as a research preview for ChatGPT Enterprise, Business, and Edu tiers. Right. And it's free for open source maintainers. So that is one paradigm. Clean, containerized, mathematical.
Automated trust.
But then we immediately juxtapose that with our second story in this layer. The incredibly complicated, messy reality of data collection out in the real world. We're looking at a major scandal involving Meta's Ray-Ban smart glasses.
This is where edge AI meets the unpredictability of the physical world.
Right, so these glasses have cameras. And the data privacy lawyers looking at this case are pointing out that these glasses are sending private video recordings back to servers.
And we're talking highly sensitive material here.
Extremely sensitive.
Yeah.
Including nude scenes, sex clips, and banking details. And where are they sending this data? To human data workers in Nairobi, Kenya.
These workers are employed by Sama, which is a data services company contracted by Meta to basically label and categorize objects to train Meta's AI.
But why is highly sensitive video from a user's bedroom ending up on a screen in Nairobi? I thought these systems had automatic privacy filters.
They do, but automatic face blurring and privacy filtering technology often fails, especially in difficult, dynamic lighting conditions. The physical world isn't a pristine code container like Ardvark uses.
It's messy.
Very messy. So the machine fails, and the architectural fallback is a human worker looking at incredibly intimate, private video feeds just to manually label what the AI couldn't understand.
And users may not even realize the glasses are recording when they speak to the AI assistant. Furthermore, there are stark warnings that in Europe, this practice currently lacks both transparency and a clear legal basis for processing.
It's a massive compliance risk.
So what does this all mean? If you are the listener, the architect tasked with building secure, compliant enterprise systems, how do you synthesize these two vastly different approaches to trust?
This raises an important question about how we construct these architectures moving forward. You were looking at two entirely different paradigms.
Yeah.
In the Codex Security example, OpenAI is using advanced AI to isolate and sandbox code in a pristine environment to verify it. It is AI checking human work to ensure safety and eliminate false positives.
Right.
In the Meta example, you have a massive corporation exposing highly sensitive real-world human behavior to underpaid data workers halfway across the globe simply because the machine labeling failed. It is humans patching the flaws of the AI's data ingestion.
It really highlights the liability gap. Relying on human reviewers to patch the fundamental flaws in your AI's data ingestion like Meta is doing with these smart glasses, it creates absolutely massive privacy liabilities. It is an unscalable, legally perilous architecture.
Completely.
On the other hand, utilizing AI to sandbox, test, and verify human-written code like Ardvark does creates profound enterprise value.
The architecture of control dictates that human-in-the-loop is necessary for legal intellectual property, as we saw with the Supreme Court.
Right, the Dave tax.
The Dave tax. But using a human-in-the-loop as a band-aid for broken privacy filters is a structural failure.
It is a phenomenal synthesis of the entire landscape today. Let's bring all of this together. As a strategic architect mapping out this space, you are navigating an incredibly complex board right now.
It's moving fast.
You are dealing with plummeting token cost and shifting integration logic thanks to GPT 5.4 and tool search, making agentic workflows actually affordable. You are managing the commoditization of edge hardware as Apple pushes the $599 A18 Pro MacBook Neo into the market, forcing you to reconsider where your compute actually happens.
Edge versus cloud.
Exactly. You are fighting the friction of intellectual property law, dealing with the Supreme Court's human-in-the-loop tax just to own your output. And finally, you are balancing the massive liability gap between automated sandboxes like Codex Security and the privacy nightmare of human data labelers dealing with failed AI filters.
It is a very delicate architecture to maintain. And as we map all of this out, I want to leave you with one final thought. A strategic question to mull over that isn't explicitly answered by the current news, but is the inevitable result of all these forces colliding.
Let's hear it.
As these foundation models get infinitely cheaper to run via API, and as edge devices get infinitely cheaper to buy at the consumer level, what happens to your enterprise economics when the single most expensive part of your tech stack isn't the compute, but the human in the loop you are legally forced to hire just to own the output?
That is the exact kind of question that defines the architecture of the future. Thank you for joining us on this deep dive into the source material. We know your time is your most valuable asset, and we appreciate you spending it with us. Keep mapping those structures, keep questioning the foundation, and we will see you next time.
That concludes our high-density weekly rundown. The signal for this week is sovereign friction. As baseline AI competence becomes ubiquitous, the battle has shifted to who owns the hardware, who owns the code, and who owns the legal right to claim a work as their own. Thank you for supporting independent, ads-free audio intelligence. I'm Etienne Noumen. Until tomorrow, stay sharp and keep unraveling the future.